Alright, we are now in this topic, the engineering soil classification. So after this one, if mahuman ako ni siya, since I will do recording of this topic, I will have our first long quiz now for this semester. So topic outline for this chapter are grain size classification, using this different standard, the USDA, MIT, USCS, AAS2, and ASTM. No? The intended learning outcomes familiarize the different grain size soil classification systems, demonstrated the use of AAS2, USDA, USCS, MIT, and ASDM in soil classification. So actually, these different standard no, have a different kanang procedure or a system in soil classification. Lahi-lahi sila og kanang ilahang standard na how to classify soil. So we'll discuss that one. The basis for soil classification. Classification is based on the following physical properties: the grain size distribution, liquid limit, and plasticity index. No? The classification gives some idea about the general behavior of soil. However, to predict true behavior, additional information based on the technical properties are yet required. For the purpose of soil classification, classifying soils into groups with similar behavior in terms of simple indices can provide geotechnical engineers a general guidance about engineering properties of the soils through the accumulated experience. So we have the simple indices, or meaning the indices ato na siyang mahimo as parameter or indicator, the grain size distribution, the liquid limit, and the plasticity index. So mo na siya atong bali yes, parameter nga so that kanang ma-determine na to if the soil is good enough or not for foundation of the building, especially kung taas ra iyang liquid limit, because that signifies the water content of the soil. So kung taas ra, meaning dili siya good no for foundation. And also the plasticity index. So as engineers, through accumulated experience niya, he or she can easily determine, no, the geotechnical engineers, if that specific soil is good enough or not for a specific purpose. Then simple indices communicate between the engineers. So we have this, after this determination of the simple indices, we'll have classification system, no, language, or those different standard that we mentioned earlier, and use the accumulated experience, no. Then estimate engineering properties, then achieve the engineering purposes. Another continuation of the purpose. Main soil types are the clay, silt, sand, gravels, boulders, etc. Above types seldom exist separately in nature. Natural soil deposits comprise mixture of above types in varying proportions, and soil classification means to arrange soil in groups and label them based on their properties and behavior. And soil classification systems also have been developed by different organizations. The different standards that we mentioned no earlier in the beginning of these slides. So there are two most commonly used systems, classification system. The engineering-based soil classification. We have the Unified Soil Classification System, or the USCS, and the American Association of State Highway and Transportation Officials, or the AAS2 system. So we have this one for the USDA classification system. For example, the sand size is from 0.05 millimeter to 2.0 millimeter, or 2.0 to 0.05 millimeter in diameter. So where is the sand? Yes, this one, no? This portion here, no? So, kani siya diri. So, the silt size is from 0.05 to 0.002 millimeter in diameter, and the clay size is smaller than 0.002 millimeter in diameter. For example, you are given different percentages of this of the soil. Then it was found out that the soil has this 35% clay, 40% silt, and 26% sand. So kung atong basihan through this triangle, no, USDA classification system, we have 35% clay. So where is the clay? This portion, di ba? Kaning nga portion dire. So clay is 35%. So we have this clay. So where is the 35%? So clay. If you try to project this 35%, we can actually this line here, straight line, the horizontal and the diagonal straight line is actually your imong basihan, no? Alignment. Imong i-align imuhang from the percent, no? Say 35%, you can extend this one to here, or you can also extend to here, no? Pwede ka dire. Then we have 40% silt. So where is the silt? So na dire ang silt. So 40%, this is the 40%. You can extend this 40 in here, dire, or you can extend dire, no? And we have, lastly, is there 26% sand. Where is the sand? So, dire ang sand. There is a 26% somewhere here, no? Somewhere here. So, if you try to extend this one, you can actually extend this one to here, or you can also extend this to here. Then, kung asa sila nag-intersect, the three, classification, I mean, three types of soil, asa sila nag-intersect, di ba, dire dapit this portion, which is part of the clay loam. So, meaning, the answer is clay loam. That is the USDA classification system. We have this Massachusetts Institute of Technology, or the MIT soil classification system. The classification system is devised by Massachusetts Institute of Technology, the USA, for dividing soil into different classes. So in this classification, the particles larger than 200 millimeter will be considered as boulders, and larger 200 is cobble. The gravel range from 60 millimeter to 2 millimeter, no, in this, and sand between 2 millimeter to 0.06 millimeter, and silt range from 0.06 millimeter to 0.002 millimeter, no. Smaller than this is the clay. Smaller than 0.002 is clay. Also, each type of soil is subdivided to coarse, medium, and fine. The Unified Soil Classification System, or the ASTM D2487, we have this history, no, of the USCS original. This system was first developed by Professor A. Casagrande in 1948 for the purpose of airfield construction during World War II. Afterwards, it was modified by Professor Casagrande, the U.S. Bureau of Reclamation, and the U.S. Army Corps of Engineers to enable the system to be applicable to dams, foundations, and other construction from Holtz and Kovacs 1981. There are four major divisions. We have the coarse-grained, the fine-grained, the organic soils, and the peat. So this peat actually this is the not good, no? This is the most expensive, not most, but one of the classification of soil that is an expansive soil, no, or more of clay, inorganic minerals. Yes, this is we discussed this one already in the other lecture note, no, previous lecture note, for the USCS, no, classification system, US Unified Soil Classification System, ing ani iyahang pag define, no, for grain size. We have the boulders. The boundary between boulders and cobbles is 300 millimeter. Then naa siya coarse fine. Then between sa coarse fine, that is the coarse and fine, no, for gravel. The between the boundary is 19 millimeters, and between the fine and coarse of the boundary between the gravel and sand is sieve, no, passing sieve number 4 or 4.75 millimeters. And in the sand, no, under the sand, the boundary between the coarse and medium sand is number 10, that is 2.0 millimeters, and medium and fine, that is number 40 or 0.425 millimeter. And beyond this number 200 or 0.075 millimeter, that is already silt and clay. This part here can be classified or can be recognized, how to say, yes, as can be, we can get the percentage of this one from here through sieve, no, using the sieve instrument, and silt and clay, we can get the percentage amount of this one through hydrometer analysis. Yes, still this is sakto ba ni siya? Alright, yes, I thought na mali ko discuss na. Yeah. Still this is a classification, no, from the USCS. We have the coarse grain. Yeah, coarse grain soil that includes the gravel and sand. Boundary less than 50% past the number 200 sieve or 0.075 millimeter, that is coarse grain soils, but greater than 50% ang nipas sa number 200 sieve, that is 0.075 millimeter, that maklasify siya as fine grain soils, or that includes the silt and the clay, no? So if the liquid limit is greater than 50, we can determine, there is this parameter, plastic limit and the liquid limit, no? And if the liquid limit is less than 50, actually we can further, no, discuss that one later. We can use the plasticity chart. Okay, the soil symbols: G for gravel, S for sand, M for silt, clay, C is for clay, O for organic, and PT is the peat. For example, we have SW, that is well-graded sand, and for SC, that is clayey sand. For SM, that is silty sand, and MH, that is elastic silt. So the liquid limit symbols, we have the H for the high liquid limit, that is the liquid limit is greater than 50, and for low liquid limit less than 50. That is why the MH here now in the example is elastic. M is the silt, then H is for high liquid limit, but dire yung giingon is MH is denoted as elastic silt. For the gradation symbols, we have W as the well-graded and P is as the poorly graded, no? Meaning sa well-graded is na-divide ang sizes in every sieve, no? And poorly graded is almost pare-pareha sila og sizes sa soil. So we have well graded if the coefficient of curvature is between this range 1 to 3, and the coefficient of uniformity is greater than or equal to 4 for gravels, and for sands is the same for the coefficient of curvature between the 1 to 3, and the coefficient of uniformity is greater than or equal to 6. We have this plasticity chart that we refer earlier. So if if the liquid limit is less than 50, we could use the plasticity chart, the CU and CC, the coefficient of uniformity and coefficient of curvature. For example, this one, the A line generally separates the more clay-like materials from silty materials and organic, and from the inorganic. So this is the A line. This one is the A line. So it states that this A line separates the more clay-like materials. The more clay-like materials is this part here. Actually, this plasticity chart is for silt and clay. This is the Casagrande's plasticity chart showing several representative soils developed from Casagrande. And the U line indicates the upper bound for general soils. So, actually, this one is for medium, medium nga pagka-clay, and this part here is for more clay-like, material. Note, if the measured limits of soil are on the left of U-line, this part here, kung left daw ang U-line, they should be a recheck, and the computation should be recheck. So this plasticity chart is this part here. The x-axis is for the liquid limit, and the y-axis is for the plasticity index. So plasticity index, remember, is liquid limit minus the plastic limit. Alright, so we have this for the U line, we have this equation, plasticity index is equal to 0.9, liquid limit minus 8. And for the A line, PI is 0.73 times liquid limit minus 20. So later now we will use this one to classify the soil. So the procedures for classification, yes, this is for the steel. Now this is still for the under the guidance of the USCS classification. So this part here is for the coarse grained materials and grain size distribution, and below this line, red line, is for the fine grained material. So for example, for the coarse, more than 50% retained in sieve number 200. So kung more than 50% ni retained, and so diri ka nga table. If less than 50% retained in sieve number 200, so diri ka. So you have to determine the liquid limit and the liquid limit. Determine the liquid limit and then the plasticity index. Then use the plasticity chart. If you are in the if less than 50% retained in number 200 sieve. Pero kung greater than 50% and more than 50% coarse fraction retained on sieve number 4, then diri ka sa gravel. Then kung less than 50% coarse fraction retained on sieve number 4, diri ka sa sand. Then less than 5% fines, more than 5%, more than 12% fine. So you have to determine the CU, or the coefficient of uniformity, and the CC. Then if this is the, kung mo fall siya ani, meaning your soil is GW, no? Depende kung asa siya mo fall. So later now we'll try to answer this one, no? Try to answer this one. We'll try to answer this one. So we are given this passing number 200 sieve 30% and passing number 4 sieve 70%. And we are also given from this now, actually this is the given, no? From here, this is the given. We are also given liquid limit as 33 and plasticity index 12. So since number 200 sieve is only 30%, meaning less than 50% ang nipas, less than 50%. So meaning more than 50% ang na-retain, di ba? 82% naman ang nipas. So diri ka sa course. So diri sa course, then pag abot nimo ani, we are also given the passing percent for number for sieve, which is 70%. And according to this, for example, in here, gravel, more than 50% course retained on sieve number 4. So dili ka pwede ani because 70% pan ang nipas. So meaning less than 50% course fraction retained on sieve number 4 kay 70% man ang nipas, no? So meaning naay 30% nga na-retain, no? Which is less than 50%. Then diri sa sand, you can only choose this one and this one. So less than 5% fines and more than 12% fines. So meaning since kaning nipas man siya og number 230%, so meaning more than siya sa 12% fines, di ba? Because beyond this number 200, this is actually for the silt and clay soil. So meaning 30% greater than 12%. So dili ka. Then we'll try to, in here we could solve actually diri pwede, you can only choose this one, is to below A line, because kay mao naman ini fall naman kaani diri, so you can only choose below A line or above A line. So to better solve this one, no, I mean see the plasticity chart, no, we could go back to this one. So naatay duha ka option dito, below A line or above A line. So that we have to determine first the PI, which is equal to 0.73 times LL minus 20. Then solve for PI. Then this one, no, your LL is given as 33. So 0.73 times 33 minus 20, which is only 9.49, which is above A line, no? Kay 9.49 naman. So kung imong tan-awon, no, to better no, see, no, kung imong i-trace this line here, it is 20. And your 9.49 is nara siya diri dapit, so which is above A line. Or yes. So above A line, so diri if above AB line, so your soil is SC. Or this is clayey sand with gravel, no? Which is greater than or equal to 15% gravel. No? So, ingana siya pag determine. Kay above A line naman ka, so automatically your soil is SC or clay sand with gravel. So, we have these organic soils. The highly organic, organic, no, I stand corrected. The peat is organic soils, no. The highly organic soils or the peat, no, group symbol PT, is sample composed primarily of vegetable soil in various stages of decomposition and has fibrous to amorphous texture, a dark brown to black color, and organic odor, should be designated as highly organic soil and can be classified as peat. So this peat is used for vegetation, no, as fertilizer, no, this type of soil. So not good actually for, because it contains decomposed materials. The organic clay or silt, group symbol of OL or OH, the soil's liquid limit in this type of soil after oven drying is less than 75% of its liquid limit before oven drying. So if the above statement is true, then the first symbol is O. The second symbol is obtained by locating the values of Pi and LL not oven dried in the plasticity chart. Okay. Borderline cases. For the following three conditions, the dose symbol should be used. So for the coarse grained soils with 5% to 12% fines, about 7% fines can change the hydraulic conductivity of the coarse grained media by orders of magnitude. Anyway, yes. The first symbol indicates whether the coarse fraction is well or poorly graded. The second symbol describes the contained fines. For example, SP, SM, poorly graded sand with silt. So this is for the um symbol, no? Symbol, how to name borderline cases and dual symbols. For example, if the soil is coarse grained soils with 5%, 12% fines, and we have dual symbols SP, SM, no? That is poorly graded sand with silt. And fine grained soils with limits within the shaded zone, the PI between 7 and 4 and LL between 12 and 25, it is hard to distinguish between the silty and more clay-like materials. So, CL, ML, this silty clay, and SC, SM, silty clayed sand. But yes, actually, we're not after of how you will name the soil or how to, because these names here is already available in the table or in what specific standard, no, classification standard. So naa na siya actually. So no need to name like what is CLML. So dili siya yung ano. Then soil contain similar fines and coarse grained fractions. Possible dual symbols is GM, ML. Alright, so we have this naming, no, from the Unified Soil Classification System. Borderline classifications. We have the coarse grained soils and fine grained soils. So this is a borderline case. Alright. Like for example, this one, gravel, GW, and GP. And the sand, SW, and SP. Note, only two group symbols may be used to describe soil. Borderline classifications can exist within each of the above groups. So we can say SP, like SPSM. Okay, then we have SCSM, SCSM, and CLML. Okay, the meaning of this one is we can actually combine the naming, no, within each of the above groups lang, like within the coarse grain soils and within the foods sa fine grain soils. For example, we have SP, the above example, SPSM. So, SPSM. So, within lang siya, diri nga group. And kung fine grains, diri ra pud ka nga group like CLML or CHML. So, yan, yun lang. Yes, another group symbols for gravelly soil. Major division, we have coarse soil, more than half of soil is retained on number 200 sieve. And gravel, more than half of coarse soil is retained on number 4 sieve. And there are laboratory classification criteria. So, na siya diri. And the group symbol, no? If this, your soil is false, this one, so group symbol is GW, or this is the well-graded gravel sand mixtures with little or no fines. And if this one, number 200, is greater than 5% and not meeting both criteria for GW, so GP. GP is poorly graded gravel sand mixtures with little or no fine. So, nga na siya, no? And other group symbol for sandy soil. So, depende, no? And group symbol for silty and clay soil. And yes, range of material percent for coarse grained soil. For example, GW, that is percent limits. If less than 15% sand, group name is well graded gravel, no? Another table for the range of plasticity and material percent for low plastic inorganic silty and clayey soil. So good ka diri from left to right jud ka, no? If the liquid limit is less than 50%, then the nature of soil is inorganic or organic. Then if inorganic, the range of plasticity, depende kung asa siya nilay, then group, then range of material percentage, and what is the group name, no? Continuation of the table. This one is, it's group symbols and their characteristics related to roads and airfields. We have example GW, value as subgrade when not subject to frost action, excellent. Then value of subbase when not subject to frost action, still excellent. Depende, we have different criteria now. And in here, we classify the soil, type of soil, or type of symbol as good or not good. Depende sa unsa iyang purpose, no? Yes, this is the continuation. Okay. Yes, this is the continuation of the description of different types of groups, no, of soil. This is unified soil classification groups. Alright. Another. Can just read this one, no? But we are not. Yeah, we are actually after of this one also. What we intend to accomplish or to achieve in this topic is that you can classify the soil according to through using the specific standard through using USCS or AAS2, no? The two engineering classification system. Another, yes, yeah, this table for the group symbols for the type of soil, then the properties, no? Kung unsa ihang properties like excellent, good, kung sa permeability when compacted, pervious ba or very pervious. Pervious is that lusot-lusot ang water, easily drained sa water, and impervious is dili siya magpalusot og water, no? Continuation of the characteristics of the soil groups, no? And relative desirability for various uses. So I think there should be a criteria for this one. Anyway, I guess anyway, okay. I'm not sure what is this number, no? Kung saan siya. I think, oh, there's 10, there is 14, critical. Wala siya gi-state, no? Kung unsa siya nga, what this number signifies, no? Kung unsa iyahang, I think this criteria, but I'm not really sure, no? Kung unsa siya nga criteria. Anyway, let's proceed now. The American Association of State Highway and Transportation Officials System, or the AASHTO. We have this history of the AASHTO. This system was originally developed by Hogan, Togler, and Terzaghi in 1928 as the Public Roads Classification System. Afterwards, there are several revisions, and the present AASHTO 1978 system is primarily based on version in 1945, according to Holtz and Kovacs in 1981. So this is katong previous na to nga gikuan ganina is for USCS, no? And this time is the AASHTO. So according to AASHTO, so for the boulders and gravel, the boundary, no, the of size, no, is 75 millimeter boundary size, and between the gravel and sand is number 4 SIP or 4.75 millimeters. And between the sand, no, under the coarse and fine, the boundary is number 40.425 millimeters. So for example, kung mo pass siya sa number 40, which has 0.425 millimeter, meaning that is fine sand. But if retained number 40, that is coarse sand. And if retained number 200 or 0.075 millimeter, that is fine sand. And if passed number 200, that is considered as silt and clay. So the same with USCS, now their boundary condition or boundary grain size sieve number is number 204, silt and clay in the sand, no? Alright. For the general guidance of the AASHTO, there are 8 major groups, A1 to A7, with several subgroups and organic soils, A8, organic soils or the A8. So the required tests are sieve analysis and Atterberg limits. And the group index is an empirical formula is used to further evaluate soils within a group or subgroups, no? We have this groups of soil according to ASHTO, we have A1 to A3, that is granular materials. That is, if less than or equal to 35% pass number 200 sieve, but if greater than or equal to 36% pass number 200 sieve, that is considered between this group or along with this group A4 to A7 is silt clay materials. So using the liquid limit and plasticity index, separate silty materials from clay materials only for A2 group, and using the liquid limit and plasticity index, separates silty materials from clay materials. The original purpose of this classification system is used for road construction subgrade rating.